In this second video, we pose a series of questions. You should have downloaded the questions and the list of primes, have something to write with, and at the end of each question you might want to pause the video so that you can decide on your answer and make a note of it, and then continue the video to the next question. Each question is in the form of a statement that you have to decide whether it is true or false based on the evidence provided. So for question 1, for these even numbers after 2, can these be written as the sum of just 2 primes? For example, 8 is equal to 3 plus 5. Try this again with an even number greater than 100 using your list of primes. So for the first question, the statement is every even number n greater than 2 is the sum of 2 primes. Do you believe this to be true or false? For these odd numbers after 5, can these be written as the sum of just 3 primes? For example, 13 is equal to 3 plus 3 plus 7. Try this again with an odd number greater than 50. Every odd number n greater than 5 is the sum of 3 primes. Is this true or false? Looking at the list of primes, there are some that differ by just 2. For example, the pairs 3 and 5, 5 and 7, and so on. These are called twin prime pairs. If we look at the list of the first 100 positive integers and remove all those that are not prime, we can mark those primes that are part of a twin prime pair. For example, 5 is part of the pair 3 and 5, and 5 and 7. The largest pair in the list shown are 71 and 73. Find the largest such twin prime pair in your list of primes. Now we know there are infinitely many primes. There is no largest one. There are infinitely many twin prime pairs, therefore. Do you believe this to be true or false? So does the list go on forever, or is there a largest pair? For these even numbers, which ones are the differences of 2 consecutive primes? For example, 6 is equal to 37 minus 31, which are consecutive in the list of primes. Try this again with an even number greater than 10. Every even number is the difference of 2 consecutive primes. Is this true or false? For these even numbers, which ones are the differences of any 2 primes? For example, 8 is equal to 19 minus 11. Try this again with an even number greater than 50. Every even number is the difference of 2 primes. Is this true or false? Calculate the powers 2 squared, 2 cubed, 2 to the 4 and 2 to the 5. And with 2 to the 0 being 1 and 2 to the 1 being 2, calculate the numbers shown. 2 to the power of 2 to the 0 and add 1, 2 to the power of 2 to the 1, add 1, and so on. Which ones of these are prime? What about the next one? 2 to the power 2 to the 5 plus 1. This statement is slightly different. It says there are finitely many primes of the form 2 to the 2 to the n plus 1. So the list is finite. Is this true or false? Calculate these numbers, which are 2 raised to a power, subtract 1. Which ones of those are prime? What about the next one in the list? There are infinitely many primes of the form 2 to the n minus 1. Is this true or false? Calculate these numbers. They are positive integers multiplied by 2 to the same power plus 1. Which ones of those are prime? There are infinitely many primes of the form n times 2 to the n plus 1. True or false? Calculate the numbers 2 times 2 squared minus 1, 3 times 2 cubed minus 1, and so on. Which ones of those are prime? There are infinitely many primes of the form n times 2 to the n minus 1. True or false? Calculate the powers of positive whole numbers raised to the power 2, so squares plus 1. Which ones of those are prime? There are infinitely many primes of the form n squared plus 1, so 1 more than a square number. Is this true or false? Calculate positive integers raised to the same power, plus 1. Which ones of those are prime? In this case, the statement is there are finitely many primes of the form n to the n plus 1. Is this true or false? How many primes are there between 1 squared and 2 squared, between 2 squared and 3 squared, and between 3 squared and 4 squared? What about between the consecutive squares of any positive whole numbers from 5 onwards? There are always at least one prime between n squared and n plus 1 squared. Is this true or false? Choose any fraction m divided by n where m and n are positive integers. Can this be written in the form of a fraction p minus 1 divided by q minus 1 for prime numbers p and q? For example, 1 divided by 2 is 2 minus 1 over 3 minus 1, and 2 and 3 are prime. 3 divided by 8 is 7 minus 1 divided by 17 minus 1, and 17 and 7 are prime. Can you find 2 other examples? Any fraction m divided by n where m and n are positive integers can be written in the form p minus 1 divided by q minus 1 for prime numbers p and q. True or false? Choose any fraction m divided by n where m and n are positive integers. Can this be written in the form of p plus 1 divided by q plus 1 for prime numbers p and q? It can in the case of 1 divided by 2 and in the case 3 divided by 8. Can you find 2 other examples? Any fraction m divided by n where m and n are positive integers can be written in the form p plus 1 divided by q plus 1 for prime numbers p and q. True or false? Choose any 2 consecutive odd primes p and q, i.e. from 3 onwards, so not 2. How many primes are there between p squared and q squared? So for example, with the consecutive primes 3 and 5, between 3 squared and 5 squared, there are clearly 5 primes. What about other pairs of consecutive odd primes squared? There are always at least 4 primes between the squares of consecutive odd primes. Is this true or false? Choose any 2 consecutive primes, p and q, and work out their difference of the square roots, the square root of q minus the square root of p. For example, with p is 3 and q is 5, the difference of their square roots is 0.5041 approximately, which is less than 1. What about other pairs of consecutive primes in the list? The difference between the square roots of two consecutive primes is always less than 1. True or false? Which of the following numbers are prime? Can you find another prime of the form that comprises only of the numbers 1? Note the ones above can be written, for example, 11 as 99 divided by 9, which is 100 minus 1 divided by 9, because it's 10 squared minus 1. Similarly, 111 can be written as 10 cubed minus 1 over 9, as can 4 ones and 5 ones. There are infinitely many primes of the form of numbers which are just comprising the digit 1. Is this true or false? Which of the following 3 numbers are prime? Can you find another prime of the form comprising a first digit 1 and a last digit 1 with all the other digits being 0? In this case, the statement is there are finitely many primes of the form 1, 0, 0, 0 and so on, 1. Is this true or false? Consider now the 2 squares shown. For the 4 by 4 one on the left and the 6 by 6 one on the right, let us remove all the numbers which are not prime. What do you notice about each row? Question 19 has the statement for all n by n squares of this form, where n is larger than 1, there is at least 1 prime in each row. Is this true or false? It's clearly not true for columns, because both of those examples have columns which do not have at least 1 prime in them. For the last question, consider the 3 by 3 and 5 by 5 tables shown and remove all the numbers which are not prime. What do you notice about each row and column this time? For all p by p squares where p is prime, as we see for the 2 examples above, for 3 by 3 and 5 by 5, there is at least 1 prime in each row and each column. Is this true or false? Now tot up all your answers as to whether they are true or false and watch the next video.